Okay, welcome to lecture Effect and Power Quality. In the earlier lecture, it has been discussed the opportunity of fact devices or fact controller in India, and what are the different uh, uh, fact controller has been installed in India. Okay, so before going to in this lecture, again remember and again recall that our objective to enhance the power handling capacity or power handling capability of existing transmission line and a proper control over the parameter of transmission line. Okay, so earlier has been discussed that suppose this is the graph for the, this is angle delta and this is power P. P delta characteristic of transmission line, or it may be a synchronous machine. We know that as the angle increases, the power also increases, and somewhere it will become maximum. So our objective is to enhance the power handling capacity. So here P is equal to, we earlier we have derived this equation. It is 0.5 E square, that is the voltage from sending end to the receiving end. Just recall it, it is the generating station or generating one. It is get transmitted through a transmission line. For our simplicity, the transmission line does not have any capacitance, only the inductance is there. A resistance also ignore, and this is to the load center. The length of the line is in kilometer. It is L in kilometer, and reactance X per kilometer. It is given somewhere. So E square upon, and here we have considered that the angle between sending end voltage and receiving end voltage, this is E1 and E2. We have considered it is even nearly same, it is equal to the E2, and angle delta is equal to 30 degree. Therefore, sine 30 is equal to 0.5. So final equation comes 0.5 E square divided by L into X. So as the length of the transmission line increases, definitely it is in denominator, and the power handling capability of the transmission line decreases. Whereas if the inductance is small, the power handling capacity can be enhanced. So if by reducing the value of X, the power handling ability or power handling capacity of the existing lines can be enhanced, and that will be the second curve. So this is the enhancement in the power handling. So even at 930 degree over there, so earlier it is going to transmit this much power P1, whereas by increasing the by decreasing the X, either by a fact controller, series fact controller, or by using bundle conductor or number of transmission line in parallel, the power handling capacity is now enhanced to the P2 value, isn't it? So to our objective to use the fact devices is to enhance the controllability or control over the parameter of transmission line, to modify the parameter of transmission line to obtain higher power handling capacity of transmission line. So under such condition, the IEEE has IEEE is defined the word, that is the flexible electrical power transmission. So what is the flexible AC transmission? Flexibility of the electrical power transmission, the ability to accommodate change in electrical transmission system or operate or operating condition while maintaining sufficient steady state and transient margin. Hence, it is not only to enhance the angle and power handling, we have to understand the transient condition and steady state stability of the transmission line. We cannot operate more than 90 degree, isn't it? Otherwise, the steady state stability, it may come out from the steady state stability. Similarly, we have to keep a sufficient margin for transient conditions, because transients are very fast and the momentum or the quantum of the disturbances or perturbation is very large. So during that perturbation, during that disturbance, our transmission line or the power system should not trip or cascade tripping or come out from the synchronism, isn't it? So the flexibility of the electric power transmission is the ability to accommodate change in electrical transmission system or operating condition while maintaining sufficient steady state and transient margin. Whereas the flexible AC transmission system, that is a fact which we are going to learn. Facts, it is defined by the IEEE is like that: alternating current transmission systems incorporate power electronic based or static controller to enhance controllability and increase power transfer capability. Means by using some electronic base or static controller base to modify the electrical characteristic of the transmission line to enhance its controllability and power transfer capability, isn't it? This is called as a FACT, means flexible AC transmission system. Whereas the FACT controller, a power electronic based system or other static equipment that provide control over of one or more AC transmission parameter. So it is a control. FACT controller is a which control one or more than one parameter of transmission line, like inductance, capacitors, isn't it? Power handling capacity of the transmission line. That devices is called as a FACT controller. Okay, so this is the basic This is the basic of the FACT controller and flexible AC transmission system. So we should keep in mind our objective to enhance controllability. Only two words. One is the controllability, and second is power handling, power transfer capability. We want to increase these two parameters with the help of FACT devices. Now, why it is needed? Say, for example, this is one generation system. It is going to transmit the power with the help of two parallel transmission lines, isn't it? Or number of parallel transmission lines to the load. Because of change in parameter of transmission line, resistance and capacitance, the one transmission line may handle more power, whereas the second transmission may handle less power. So with the help of FACT devices, we can improve or we can modify the electrical characteristic of these two transmission lines in such a way that the infrastructure can be utilized very effectively. Very effectively means we can use these transmission lines to transmit large amount of power. And why it is needed? It is very simple, because our generation pockets is in the eastern region, whereas load pockets or load centers in the western region. So to transmit the power from generation ends to the load end, the length of the transmission line is very high, and in case of EHV transmission system, as the length increases, the power handling capacity of the transmission line decreases. So these are the some important point to remain in our mind while discussing the this course. Okay, so what are the different controller? The different controller are the series controller, shunt controller, combined series controller, and combined series shunt controller. Okay, so now we'll see one by one what are the different type of controller and their objective. So now first is the series controller. Series controller, basically, this is the symbol of fact devices. This is the symbol of fact devices simply, and either it can be used as a shunt in parallel or in series. So it becomes a series controller and shunt controller. Okay. Now the series controller, uh, could vary impedance like inductor, inductance, and capacitance of transmission line. So the series controller may be variable impedance. It may be a variable impedance such as capacitor or inductor, or power electronics based variable source of main frequency. So this controller may be a variable impedance. Variable impedance is comprises of inductor as well as capacitor, or it may be electronic based variable source of main frequency, that is the fundamental frequency, and subsynchronous frequency for it is used only for the harmonic distortions, isn't it? The basic need of the series controller, this is our basic need to controller inject the voltage in series with the line. What it means, say for example, this is the current for any case. Okay, so first we'll say basic one. Say this is the voltage V and this is the current. Okay, at an angle of theta. Okay, so current has two components. One component in phase with the voltage. So this is one component I1, and the second component in quadrature. So the active power, we can say that V, this is I cos theta. Okay, this is I cos theta. This I1 is nothing but I cos theta. So the power, active power is I cos theta, whereas the reactive power is equal to V into I sin theta, isn't it? Means when the current in quadrature, it deals reactive power, and when the current in phase, it deals only active power. So the series controller inject the voltage in series with the line. It will inject the voltage in series with the line. Even variable impedance, either it may be impedance, it may be a capacitor, it may be an inductor, or impedance. Variable impedance multiplied by current flow through it represent the injection of series voltage. So basic need of the series controller is to inject the voltage in series, and it will inject the voltage in series as long as the voltage in as long as the voltage, the current and the injected voltage in quadrature to each other. Say this is the current and this is the injected voltage. Okay, so under such condition, as long as they are quadrature with each other, phase quadrature, that is 90 degree to each other, it supplies or consume, means the series controller supplies, try to understand, supplies or consume reactive power. See here, in the basic idea, if voltage and current, they are quadrature to each other, only the reactive power will be there, isn't it? Suppose this is the current and this is the voltage. Definitely it is in quadrature. This is voltage and this is current. What it will be there's a reactive power. As the current in this case, it is a lagging one. So inductive reactive power. Whereas if the current and voltage, no doubt again it is in quadrature, this is current and this is voltage, but here the current is leading, so it will be a capacitive reactive power. So as long as the series controller inject voltage in series with the voltage. It means that current and voltage, those are in quadrature or phase quadrature. So either the series controller supplies or consume reactive power. Whereas at any angle less than 90 degrees, suppose this circuit, this diagram, it is less than 90 degree, it supplies or consume reactive power as well as active power, isn't it? If the current in leading side, it will supply the reactive power. When the current is lagging side, it will consume the reactive power. But if the injected voltage is not in phase quadrature, under such condition, it supplies or consume reactive power or control reactive power as well as the active power. So in case of the series controller, when it is connected into the transmission line, it control active power as well as the reactive power. By this way, it will enhance the power handling or power transfer capability of the transmission line. So this is called as a series controller. Second is the shunt controller. Similar to the series controller, the symbol is same, only it is connected in parallel, either from the mid of the transmission line, receiving end or sending end. The shunt controller may be a variable impedance and variable voltage, variable source, or combination of these two. Similar to the series controller, either it may be a variable impedance. Variable impedance comprises of the inductance as well as capacitance, and variable source, similar to the series, but it is connected in parallel. The basic principle of all shunt controller, whatever the different type of controller we are going to learn, all the basic principle or basic requirement is that it inject current into the system at the point of connection. Whenever you are connecting the controller at the sending end, either it will inject the current or it may consume the current, depend upon the variable impedance. Either it is a capacitor or either it is an inductor. If it is an inductor, it will consume the reactive power or current, and when it is a capacitor, then it will supply the reactive current and power, isn't it? At the point of connection, either it may be center of the line, either it may be the receiving end of the line. Even variable shunt impedance connected to the line, voltage cause or variable current flow and hence represent the injected current into the line. Definitely, if you are connecting here, it may represent the injection of current or consumption of the current with the help of, as long as, this is again very important, as long as the injected current in phase quadrature with the voltage, the shunt controller only supplies or consume reactive power. Only supplies or consume reactive power. So I just repeat it. As long as the injected current, because it may be a capacitor, it may be inductor. So in case of inductor, it will consume the reactive power. Just I will draw here. Suppose this is the reactor, so it will consume the current, isn't it? And if suppose it is a capacitor, means the controller is a capacitive controller, so it will supply the reactive capacitive current, isn't it? So as long as the injected current in phase quadrature with the line voltage, the shunt controller only supplies or consume variable reactive power, isn't it? So as long as this is a pure one, either it will consume or either will supply. In this case, it will consume. So it is a consume the reactive power, and in this case, it will supply the capacitive or reactive power, isn't it? So our objective is to handle this current. If it is not in phase quadrature, definitely in addition to the reactive power, it also handle the active power. Okay, active power. But our principal requirement of the shunt controller either to inject current or consume current in phase quadrature, isn't it? So this is the shunt controller. Third is the combined series controller. So this combined series controller is used for parallel transmission line to control the power handling capacity of the transmission line, or to use the proper infrastructure which already we have discussed. If suppose this is the two transmission line and these transmission line parameters are different, and because of different parameters, even though the length of the transmission line is same, it does not handle the same amount of power. To create a same amount of power to be handled by the transmission line, a series controller can be used. So this series controller is independently a controller, but it is connected either in coordination or with the help of DC link, which deal active power exchange between the two transmission lines, and it will increase the power handling or power transferability of the transmission line. So this could be a combination of separate series controller. Either it may be a separately acting as a two series controller, or control in the according manner some with the protocol of the transmission line. It can be used as a unified controller. Whenever the unified controllers are there, active power also deal with the help of series controller. Similar to the combined series controller, there is a combination of series and shunt controller. So it is a either it may be controlled independently. So here the independent control is there. Shunt controller is working independently and series controller are working independently, or it may be coordinately controlled for fruitful result of the transmission line. So there are either it may be a series controller, it may be a shunt controller, it may be the combination of shunt and series, or it may be a series controller. So there are different type of shunt and series controllers are there. Now, before going to the shunt and series, there are some different advantage of series controller and shunt controller. Series controller capacity is much more smaller as compared to the shunt controller. Means the MVA rating of a series controller is smaller as compared to the MVA rating of shunt controller. So definitely the series controller is economical as a point of view. And second, it will increase the power handling capacity of the existing transmission line. So we generally use the series compensator. As earlier we found that in our scope of FACT controller in India, or opportunity of FACT controller or FACT devices in India, we found that there are number of FACT controller, those are connected in series, isn't it? This is the one. Second is that the series controller deal reactive and active power both. So it is much again advantage. And MVA size of the series controller is smaller. These are the some points to be important while considering or while selecting the different type of FACT controller. Okay. Now there is a one more controller that is it is a series controller and it is a shunt controller, but it is equipped with the storage system, isn't it? And this storage system may be a battery, it may be a superconducting magnet. The benefit of added energy system such as a large DC capacitor, you can use as a charge DC capacitor. It may be a battery storage system, it may be a superconductor magnet, because superconductor magnet also a good for energy storage system. And it has some different significance. The significance of this storage system either in the addition of capacitor, storage system, or battery storage or superconductor, it add a new dimension in the controlling of parameter. What is that? We know that in the transient condition, say there is a transient fault or transient disturbance are there. Okay, so this is the time and this is the magnitude of transients are there. So during the transient 1.5 cycle, after that there is a oscillations in the system. Okay, so 1.5 cycle, you may be considered as a transient, and whereas rest of the time or the way of transient or way of the power system reaching to the new equilibrium position, say delta 0 to delta 1, it is called as a dynamic behavior of system, and it is depend upon the size of the system. It may be depend upon the size of system and parameter of the transmission line. If the transmission line having resistance, the damping can be oscillate very easily. So during that damping, this storage system play a very important role. So it will die out the damping and enhance the dynamic stability of the system. So to increase the dynamic stability of the transmission system, dynamic stability of the power system, this storage system is associated or it is connected with the series controller, shunt controller, and combined series and shunt controller, isn't it? So this is the use of battery storage or some different kind of storage system in conjunction with the controller. Okay. Now, shunt controller, which just we have discussed, what is the IEEE terms are there before going to the shunt controller in detail. Just as we have flexibility of the electric power system, power transmission, the ability to accommodate change in electric transmission system or operating condition while maintaining sufficient steady state and transient state. This is very important. We want to keep the system to be stable, and we want to modify the electrical characteristic of the existing transmission line. So that is called, if you are able to modify this change, it's called as a flexibility of the electrical power system, and that flexibility is obtained by some FET devices or FET controller. Similarly, the flexible AC transmission system, that is a FET, alternating current transmission system, incorporate power electronic based or static controller to enhance controllability and increase power transfer capability. If we are increasing these two parameters, number one, controllability of the transmission parameters and transmission system. Second, to increase the power handling capacity of the transmission line, it is called as a FET or flexible AC, because it is flexible in operation and maintaining steady state and transient stability. To obtain this one, we need some controller. So power electronic based system or other static equipment that provide control over one or more parameter of the AC transmission system, it is called as a FET controller. So the FET controller may be an electronic base, it may be some static base, and which provides enhancement in the controllability and power handling capacity of the existing transmission line. It is called as a FET controller. Now, static synchronous compensator. The static synchronous generator operate as a shunt connected static VAR compensator whose capacitive or inductive output current can be controlled independent of the AC system. So static synchronous generator whose injected current, either it is injecting, either it is consuming, it is independent of the voltage or independent of the system voltage. Either it may be a 132 kV transmission line, 220 kV transmission line, but it is controlled independently. Then it is called as a static synchronous generator, isn't it? The STATCOM is a one key fact controller. It can be based on voltage source or current source. So either it may be a voltage source or either it may be a current source. So there are two diagrams here. This is the voltage source. This is voltage source and this is current source. Okay. So this fact controller or STATCOM has two types. One is the voltage source converter, voltage source base, and second is the current source converter base. So in the voltage source converter, the thyristor is connected with the in parallel with the diode, and whereas it is connected in series. For the voltage source converter, a charge capacitor is used as a voltage source. So see here, it is a as shown in diagram. The voltage source converter and current source converter, I mentioned before, from overall cost of point of view, voltage source converter is preferred as compared to the current source converter. And again, in case of the static synchronous compensator or STATCOM, we are using mostly the voltage source converter because economically it is cheaper as compared to the current source converter. So today's lecture, we will stop here, and next time we will see the different type of fact controller and shunt connected fact devices.